Good afternoon, everyone. Tractor Man 44 here. In the old days, well, I'm actually a retired air conditioner mechanic. I pretty much did commercial air conditioning exclusively for the last 25 years, close to 30 years, I guess. But I've been involved in commercial and slightly residential and even industrial refrigeration, air conditioning, boiler, chilled water piping, chiller plants, things of that nature for 42 years, I think, something like that, give or take. At any rate, done a pretty good gambit of things all the way up to DDC controls and stuff, but that's neither here nor there. That ain't what today's about. That's just a bunch of baloney, I guess, don't matter. When you get old and retired and everything, you kind of become insignificant, except to a few of your family members and select friends, so to speak. But anyway, I got an old buddy. His name is Dozer Dave. His name is Dozer Dave simply because that's what he does, man. He works on heavy equipment. So I kind of tagged him with the name Dozer Dave a while back. He's a pretty good old boy. But at any rate, he's got a situation where he needs a little more heat down in the basement off of his wood-fired boiler. And the upstairs does just fine. There's a hot water coil in the plenum of the furnace, and it satisfies his house. But downstairs is a little cool. So we come up with the idea of putting this little fan coil down the basement between his pair of studs, and he's going to get about a 350 CFM fan somewhere around that area, and he's going to go ahead and turn that on and blow some heat into that downstairs family area. But at any rate, here's what we got. It's even marked Dozer Dave's coil here. What we're going to do is we're going to take this coil, we're going to fabricate some sheet metal. Oh yeah, I forgot to tell you, I did a little bit of that, way back in the day, I ain't really a tinner by any stretch of the imagination. I wouldn't even make a scab on a real tinner's bottom, But at any rate, we're going to take this little old coil here. It's a 3-pass coil, and we're going to hopefully get about 4 gallons per minute water flow through it, maybe 2.5 to 4 at 170 degrees. And we're going to make an adapter that goes from here down to where you can put that little squirrel cage or that little paddle fan, and then make a set of flanges for the other side where it'll screw right onto his studs. So that's the project for this afternoon, guys. I'll try to make it less boring, the least boring as possible. There's really only a few basic tools you need. You need a pretty good pair of 10 snips. Some guys like them old dogs, but I kind of like these guys here. A little scribe. Take a piece of stainless steel and you can mark it in 1/4 inch, 1/2 inch, 3/4 of an inch, and then 1 inch. And that saves you a lot of measuring, whenever you want to mark around the edges, And then I like to use an ice pick, simply because it gives me a nice sharp scratch line on the sheet metal, lets me see it. And also it's on a 4-foot sheet. I'm a little bit on the short side. I'm vertically challenged, like they say, being politically correct. And that ice pick allows me to reach all the way across the work table the other side of that 4-foot sheet of metal. And then of course you got to have a rule. Now you don't want just any kind of rule. You want an inside read. You don't want one of the ones that read on the outside. And that's very easy to see, because if you're marking something that's less than 2 feet long, you don't want to have to mark like this and bend your rule and all that. So you want to be able to lay it down and mark, right against that. Plus, those numbers are the ones that you use continuously. And if you have an outside read rule, those numbers get wore off pretty quick. So anyway, that's basically what you need. That and once you grab a piece of metal big enough to make what you want, or at least one portion of what you want, time to figure out how you want to lay it out. Now there's this particular seam that it's a locking seam called a Pittsburgh Lock, farmed by a lock farming machine, obviously. And it takes up 1 inch material, so anytime, whatever dimension you add that lock to, you are always going to have to add 1 inch to that dimension. But you also remember we talked about having a flange. Well, I only want a 1/2 inch flange on this thing bent to the inside, so I'm going to start off with my 1 inch scribe. Now I'm going to put me a 1 inch scribe down here, and simply because it's a 1/2 inch double hem to the inside, I'll mark a second 1/2 inch right there. Okay, well, the next thing we know that thing needs to be 18 inches, so if that's 18 inches, we can have lock farmer the Pittsburgh Lock on the 2 outside edges, that's going to end up being 20 inches. So what I'm going to do is I'm going to come in here. I'm going to come in here at 10 inches because 10 is half of a 20. This is the cool thing about a two-way transition that's equal, and you'll see this in a minute. Now the length of this is going to be 15 inches long, but I have to add 1 inch to the 15-inch dimension for the flange, so that's going to be 16 inches in length. So I just mark 16 here, and I'm going to have another layout down here, so I'll go ahead and mark 16 here, and that way we get that line scribed for both of them. You know, it'll be a done deal. We'll go ahead and establish that line. I know you can't see the... Okay, so if we came in 10 inches here, we need to come in 10 inches up here too, simply because that's going to establish our center of the 7.5 inch small dimension. Okay, half of 7.5 is 3 3/4. So all I have to do is come in here at 3 3/4 off of that center mark and make me a mark. Come over here, 3 3/4 off of that center mark and make me a mark. And I want to mark that down 1 inch. That'll come into play in a little bit. So we're going to go ahead and mark a 15 here and a 15 here, because again we're going to use this other half of the sheet. Okay, so now we got our whole 1 inch mark established for 2 pieces of metal. 2 of the 4 pieces of the duct. So now we have this established up here. That's a 7.5 inch dimension. Down here we know it's going to be 20 inches wide, but we have the center. So if I come over here 9 inches, because the duct is actually going to be 18, and I'll mark me 9 inch off center. 9 inch off center. Now we'll connect the dots. We'll go from this 9 inch dimension down here on the flange all the way up here. The same thing here on this. Transpose that down. There we go. Now you got to add your 1 inch to it. But you can't just add the 1 inch down there. You have to actually put it out at the angle that your transition is going to be. So now that we have that actual angle established, we'll mark an inch. An inch. This is again is going to be taken up by that Pittsburgh Lock when it goes through that lock forming machine. Add an inch here. Add an inch here. And then go ahead and mark that. Cool thing about an equal transition is you only have to lay out half the piece of duct, simply because once you get one side laid out, you invert it or invert it and use it to become the pattern for the other identical one that has to be from the opposite side. So what we have to do now is wipe this out. Done already. So I'll do that and I'll be back with the other side. Now what I like to do on these is simply because this is light gauge metal, well it's 26 gauge. A lot of duct that's in residential places are 28 gauge, but this is 26 gauge. It's heavy enough, but if there's any amount of duct static pressure, that's the amount of pressure your blower is exerting on the insides of the duct, you know, in order to force them out of the register. If there's any amount of pressure in the duct at all, your duct is going to oil can. So what I like to do before I run it through the lock former machine is I like to put a cross brake on them. Now this particular brake, if you take a look at it, it's an 8-foot 18 gauge Chicago brake. I don't know how old it is. I really don't know how old it is. Just last week I run across an old timer. Well, actually I run into him a year and a half ago or so, and presented the idea that whenever he wants to get rid of this thing, he should consider me to make the purchase. So yeah, the Clear Blue Sky, he called me a couple of weeks ago and told me he's ready to sell it. So I went out last week and picked it up. I have yet, this is going to be the very first piece of metal I've actually stick in the jaws. You can still see how rusty it is. Been sitting in his barn. He said he hadn't touched it in over 20 years. And he's not bent anything except for aluminum, so there's no bend marks or anything messed up on the apron or any of that stuff. in the bending edge. But at any rate, this is the very first piece of metal that I've ever bent with it. Hopefully there's going to be a lot more. Or, if the right guy comes along, I might sell it to him. Now somewhere inside here with all this camouflage around it is my 20 gauge lock former machine. It's the machine that creates the Pittsburgh Lock. Into one piece of duct. Of course, we have to fold the flanges, and that'll be the next project or the next step in the project, but before we make the sides, because we have to get the measurement from this point to this point. I don't have a computer program to figure that for me. So at any rate, we're going to go back over there and fold these up. The next step is that 1/2 inch double hem flange. Remember, we took the scribe and we marked that 1 inch, then we flipped it and marked it a 1/2 inch. That's going to allow us to fold the first 1/2 inch mark in, and then the second, or the 1 inch mark, then in again. That's going to give us a 1/2 inch double hem inside 90-degree bend. We're going to fold the two sides, which should look very similar to this. So now that we got the flange bent on there and everything, let me make sure it's in the camera here. Yeah, it looks like it is. We need to measure from right here to right here, and then add 1 inch for the 1/2 inch double hem flange that folds to the outside on the sides, and then we have to add the 1 inch here because that's going to be the part that actually puts the end cap on. Now, I know there's real tenners out there. If any of them accidentally tune in and watch this, are probably just laughing their tail ends off and everything, you know, because obviously, you know, a tradesman himself that's actually in the trade, you know, knows all the mistakes I'm making, and I know some of the mistakes too. I just ain't telling you all about it. But the main thing is we're going to end up with something that we're not going to have to use duct tape on or caulking on, and it's going to keep the air on the inside of the duct, and it's going to make my old buddy Dozer Dave's basement a whole heck of a lot warmer. So at any rate, there is the first half laid out. So let me go ahead and cut this up here on this end. Our pattern for the other half. I'm just going to invert it and go around it, trace it, cut it out, and we got our 4 pieces almost ready for assembly. So here we go. We're getting ready to bend the 1/2 inch double hemmed 90-degree edge to the outside. So I'm going to slide this all the way in, just leave a 1/2 inch sticking out this time. I'm going to do it a little differently. Wrap this all the way up to the top. Open this up, slide that under just a little bit, then latch this down. That's folded to the outside now. There's going to be the side of the duct, either the left side or the right side, again, because it's an equal transition or equal taper. The other dimension is 18 inches up here down to 7.5. This is 12 1/4 to 7.5. We're going to have an end cap on here, and we're going to have that blower attached in the end cap. Okay, there's one thing I forgot. Whenever you're making that transition, of course, everything's got an angle. I forgot to put this little bit of an angle back out to correct for the transition as it's going down and then cuts back out. And conversely, on the other end, you have to put that same angle the opposite direction. Okay, now, Bear in mind, this particular machine here is called a Cleat Bender. The things that you attach ductwork together with is called drive cleats. And so this is a Cleat Bender that's going to make a 1/2 inch reasonably perfect 180-degree bend on that without distorting the rest of the piece of metal. You can put that drive cleat on in individual pieces like this, or wait till the whole assembly is assembled and then just do the two portions. But I don't get to this tool that often. I've got it packed up. I've got a tractor frame here to the left, an old Alice Chalmers C. I've got a make and break economy engine right here underneath it in front. Yeah, this is very difficult to get into. So conversely, it's going to be very difficult for me to utilize this machine correctly with you guys looking over my shoulder. There you go, both of them done. Let's go back and assemble. Okay, it's about time to assemble this thing. This is kind of a difficult time because it looks like it'll be easy, but because it's all these different angles, it is just a little bit aggravating sometimes. Getting the first one on is the toughest. Now I got a real neat tool. I think you guys are going to like this next tool. It's an electric hammer. See how nasty this looks? Well, you can take your time and beat the hell out of it with a hammer, but this works a whole lot easier. Pretty nifty, huh? But at any rate, this is pretty much like the drawing I got. This is the top, 18 inches wide, 12 1/4 inches tall. We have an equal transition, in other words, a center line transition that goes from that dimension to 7 1/2 and from this dimension to 7 1/2. Now I have to fold up an end cap, put an end cap in it so we can install the fan right here. Then this is going to attach right onto that coil over there. Here's the coil. As you can see, this is going to attach right here by those flanges on the side. May or may not put just a rubber gasket under there. I don't know that he's going to. If we have just a tiny bit of leakage, it's just going to be in his basement anyway, and that's the space he's wanting to heat. So it's not a big deal. So it looks like it's going to fit just about the way we wanted it to. Remember we talked about the drive cleats? Here's your actual drive material or drive itself. You buy them in 5-foot lengths or 10-foot lengths, either one. So I'm going to cut this a little bit long. We just cut it off about so. Make a second one because you have to have two of them, one for each side. All right, and what I like to do is take and trim that inside out just a little. Okay, we're going to make a 7 1/2 inch end cap. Let's verify that our duct actually turned out 7 1/2 by 7 1/2. So we just go across our drive to drive. I don't know if you can see that or not, but it reads exactly 7 1/2 inches. And if we go from our S to S, center of the S to center of the S, you can see it's pretty doggone close to exactly 7 1/2. So there is a little bit of flex this way or that. So if it's a little bit this way or whatever, it's not a big deal. Okay, so we know we have a finished product of 7 1/2 by 7 1/2. So we have to add an inch on all four sides because it takes another inch to make the drive cleat and it takes an inch to drop down inside this S-clip. So our layout or our cut size on the layout is going to be 9.5 by 9.5. So I'll get a scrap piece of metal, we'll lay that out and come back. Okay, on the end cap we said the cut size is 9.5 by 9.5. So we're just going to go ahead and mark 9.5 here. Now when I'm in a regular shop, I got a big old T-square and everything. I usually use that big old T-square. I don't have to do quite so much measuring. But what we're going to do is we're going to take the 1 inch and we're going to measure, we're going to scribe 1 inch all the way around the perimeter. There you go, 9.5 by 9.5, and we're ready to fold the drive cleats, the S-bends, and we're essentially done. And what I did, I made my way back into the Cleat Bender and did the first 2 bends because it's so much easier and much more accurate or consistent, I guess, if you fold those drive tabs on that Cleat Bender. But otherwise, you'd have to do it out here on this. But anyway, we fold those that direction, and then it's time to fold them back 90 degrees the other way. We have a ready to assembly end cap. Went a little bit over 90. Like I say, I'm not used to this brake yet. This brake is just a little tight. It's going to take a little bit of use to finagle it, to finagle some perfect bends out of it. But it'll come in time. Well, let's go put this thing on, man. Well, like I showed you, we got the end cap completely done. We've got our drive cleats on here, and we've got our 90 degree, 1 inch 90 degrees to fit down into the S's. So all we have to do is come over here and slide those guys right down into the S's like this. Just slide one side in, pick up our drive cleat that we prepared by cutting that notch, slide it right in here and right on down, drop the other side down, grab the other drive cleat, and slip it right along there. And whenever I get done, we get ready to install it. I'll actually trim this off perfectly about 1 inch beyond, put some little angles on the end to kind of trim it up, bend it with a pair of folders to get us a perfect 90-degree bend, and latch it down nice and tight. Do that on all 4 edges, and then there won't be anything except for just a very small pinhole at the 4 corners that'll leak just a little bit of air. But at any rate, that's pretty much it in a nutshell. All I've got to do now is get the fan assembly, and I'll cut the diameter of the hole where that fan assembly will actually insert down inside. And then whenever I cut the hole, I'll prepare it by cutting a tab on the 4 corners out of that plug that I cut out of it, bend the tab up, and then we just use some little bitty short 3/8 inch long screws, tech screws, to screw right into that fan to hold everything in place. And I'm going to cut it as tight as I possibly can. It's probably not going to leak very much at all, but if it does, you could put just a little dab of caulk around, but that very seldom ever happens. It's usually pretty doggone tight. So anyway, that was just an attempt at showing y'all how the basic layout is on a piece of duct. This ain't a standard piece of duct, of course. It's not rectangle at all. It's a two-way transition. But I just thought it'd be nice to kind of let y'all see, you know, how you go about laying it all out. I'm not a professional. Heck, I don't do this for a living. I've been known to do it way back in the past when I worked for a company. Oh my Lord, back in the 70s, early 80s, I guess. But man, I haven't done hardly any tin work at all to speak of for a long time. And I am not a tinner by trade at all. But at any rate, and most of you guys ain't going to have access to the tools and equipment that I've got. I've been collecting this stuff. Hell, I've been collecting this stuff for 42 years, you know. So everybody ain't got access to it. But I'm blessed with I have been blessed with the opportunity to buy things fairly reasonable, you know, and put together a pretty decent shop. This is going to be a dry fit. As you can see, I cut the end cap, and whenever I cut the end cap, like I told you, I was going to leave several tabs around the perimeter so that we can screw into the plastic shroud or the plastic portion of the inline fan. So I cut the hole. It should slip right down in there. I should be able to put 4 tech screws right in there to secure it. Well, let's take a look at this little fella. It's an inline, 6-inch inline fan. It's a little paddle fan, or a blade fan, not a squirrel cage. It's a Ronier ROWNEER, Ronier 6-inch inline duct fan, 110 volt, 70 watts of power, 2400 revolutions per minute, or RPM, and 390 CFM. He'll be able to balance the water, the gallons per minute going through the coil by means of a valve. We're not going to put a circuit setter on it or anything like that. And then he'll be able to tailor the airflow as to what he's going to need to satisfy the heat load within that basement entertainment area. So at any rate, like I said yesterday, this has been a fun little project. It really only should have taken, you know, an hour, you know, to make this whole thing. But yeah, it takes a little bit of time moving the silly camera around and digging out my tools. Obviously, I do not do this every day, but whenever I do it, yeah, I have fun doing it. So at any rate, I do sincerely hope you enjoyed it. It's Tractor Man 44, man, and I am out of here.